Okay, so this is problem 10.2.67, and they ask us in this problem, how many anagrams are there of this I-N-E-I, I guess that's an I, B-N-B, or palindromes, okay? So an anagram is just another way of writing this, and a palindrome is a word that reads the same forward and backwards, okay? And they gave you an example in this problem that as an example of a palindrome using these particular letters would be this word right here, I-N-B-E-B-N-I. So you can see it's in Bimni, either way you read it. Okay. So the way that you have to do this is you kind of have to analyze what letters are being used and how you're going to think about it. So the first thing is just notice that E is the only letter, and I'm going to go ahead and cross this off because I think this is going to be confusing for us. We're working with these right here. The only letter that isn't repeated here is E. And so if you're going to write a palindrome and it's going to read the same forward and backward, E is going to have to be your middle term. It absolutely has to be in the middle. If you notice that there are seven, there's two I's, there's two N's, there's two B's, and there's one E. Okay, so there's seven total. The E has to be in the middle. You're going to have three things on the other side of it and three things on the other side of it, and they need to go the same way. Okay. All right, well, at this point, there's only one way to choose this E being right there. And so then what you're thinking about is, okay, what I have left is I have three letters to choose from, and I could put any of those three letters in this slot right here. This could be an I, an N, or a B. So I have three choices for that slot. But whatever I choose for this slot, like let's say for instance I choose an I for this slot, then this slot also has to be an I. So I actually only have one choice for this slot right here, because it has to match whatever I've chosen over here. Okay, now once you've chosen this, if you choose for instance an I right here, then you have two choices left for this slot, because you can't choose another I because it won't read the same back and forth. If you choose an I here, there has to be an I here. So then you have to choose another letter. There's only two left, so you have two choices for this slot. And whatever you choose right there, it has to be the same one over here, so you only have one choice for that slot. And then you're down to the last letter here. You have one choice for this slot and one choice for this slot. So if you were to use the product rule here, the fundamental counting law says that we would multiply all of these. You just have 3 times 2 times a bunch of ones. So you end up getting six different palindromes for that. And we could actually probably write all of them out if we wanted to. Well, maybe I'll do that. So you could have an I here, that would need an I here. You could have an N here, that would need an N here, and a B there, and a B there. Okay? You could have, they didn't ask you to do this in the problem, I'm just doing this to help explain. So you got to have your E in the middle. You could have your I here, and you could have your B here, and then your B here, and then your N, and then your N. Okay? So that takes care of the situations where I is first. Then you can take care of the situations where N is first, and I think you're going to see pretty quickly the pattern. So if N goes first, then N has to go last. I could choose I to be second, and then I has to be second to last. And then I could choose B, and then I need to choose B. And so then you would just keep going if you wanted to list all of them out. But using the counting techniques, there are just six ways to do this.